Guidonia Airfield, Rome, June 1943. Chief Engineer Filippo Zappata wiped the perspiration from his brow as he circled the aircraft resting on the tarmac under armed guard. The American twin-boom fighter gleamed in the Mediterranean sunlight, its aluminum skin unblemished, save for a few minor scratches from the emergency landing in Sardinia 3 days prior. A navigational error had delivered this technological marvel into Italian hands. A Lockheed P-38G Lightning, completely intact, with both engines still warm from the flight northward. When Zappata first laid eyes on the P-38 on the tarmac, his reaction mirrored that of every Italian pilot. The unconventional twin booms flanking a central fuselage violated every aesthetic convention. The senior propulsion engineer of the Royal Italian Air Force, Zappata, was a seasoned expert who had dedicated 15 years to designing and evaluating aircraft engines for renowned manufacturers like Fiat, Alfa Romeo, and Isorta Fascioni. His extensive experience included examining captured British Spitfires, studying Soviet Yaks, and analyzing German designs. 148. As Zappata began his meticulous examination, the engineer who trusted in numerical data was about to confront an unimaginable truth. The P-38, often nicknamed Il Diavolo, a Dew code, or the twin-tailed devil, by his colleagues, was not ungainly as presumed. Instead, it represented a prophetic revelation, with its components serving as mathematical proof that Italy had already lost a war its leaders still believed they could win. 127. The P-38's elegant Italian design, which embodied the principle of refined aesthetics, had long been the subject of both admiration and mockery among Zappata's peers. However, the nickname carried more derision than fear, as the engineer was about to uncover the profound implications hidden within the aircraft's intricate engineering. 056. Chaos. Zappata believed he grasped the state of aviation engineering in 1943. However, he was about to realize the depth of his ignorance. As his team of engineers approached the Lightning with their toolkits and measurement devices, a sense of dread gripped him. The Americans had dispatched this machine across an ocean to fight in a distant war. This alone suggested an industrial capacity that Italy could scarcely fathom. Yet, it was what lay within those engine housings that would unveil a truth so devastating, it would haunt Italian aviation engineers for the rest of the conflict. They weren't merely behind. They were hopelessly, irrecoverably outmatched. The P-38 Lightning embodied everything. Italian aeronautical engineering was not without its merits. While Italian fighters were sleek, lightweight designs that maximized performance with limited resources, the Lightning was an American behemoth, massive, intricate, and powered by an engine technology that Italian factories could scarcely replicate. Zappata knew the specifications by reputation. Twin Allison V1710 engines, turbocharged counter-rotating propellers, and a tricycle landing gear. On paper, it seemed almost extravagant, 2 engines where one should suffice, unnecessary complexity, the quintessential American excess. But Zappata was a scientist, and scientists do not rely on reputation alone. They trust empirical data. His team spent the first hour simply documenting the external dimensions. The Lightning's wingspan stretched 52 feet, reasonable for a fighter. But the weight, when they meticulously calculated the loaded weight based on structural analysis and fuel capacity, and the figures were truly staggering. Weighing in at nearly 18,000 pounds fully loaded, the aircraft was almost twice the heft of Italy's frontline fighters, the Macchi C-202 and the Fiat G55. How can something this heavy even take to the skies? Giorgio Mancini, Zappata's assistant, muttered as he dutifully recorded the measurements. That's precisely what we're about to uncover, Zappata responded, though he already had an inkling that the answer might be unsettling. The real examination commenced when they opened the engine cowlings. The left engine port side was the first to be revealed. As the panels swung away and the Allison V171049 engine came into view, Zappata's engineering team fell silent. It wasn't the size of the engine that had caught their attention, though the 12-cylinder. The colossal liquid-cooled V-configuration engine was a marvel of Italian engineering, surpassing the nation's typical standards. It wasn't merely the exceptional quality of the machining, with each component gleaming with a precision that factories struggling with material shortages and Allied bombardment could no longer replicate. The true innovation lay in the turbocharger system. Zappata had studied intelligence reports detailing American turbocharger technology. While the concept was not entirely novel, using exhaust gases to spin a turbine that compressed intake air, allowing engines to maintain sea-level power at high altitudes, had been explored by German engineers. Italian designers had proposed similar ideas, but no one, not the Germans, the British, or the Italians themselves, had successfully integrated a turbocharger into a production fighter aircraft. The United States had already accomplished this feat twice, with each engine taking a mere 5 minutes and 41 seconds to assemble. They were now producing hundreds of these aircraft every month. The turbocharger assembly was situated behind and below each engine, connected by a complex network of exhaust ducting that snaked through the intricate tail boom structure. Carefully examining the turbine wheel, Zappata marveled at the masterpiece of metallurgy before him, a precision-forged component designed to spin at over 21,000 revolutions per minute while withstanding exhaust gases exceeding 700 degrees Celsius. "What alloy is this?" Mancini inquired, tracing his fingers along the turbine blades. Zappata shook his head slowly, acknowledging that the proprietary material was likely a closely guarded secret, one that they did not possess. The P-38 Lightning was a formidable American fighter aircraft during World War II. Each P-38 engine, equipped with a turbocharger system, could generate an impressive 1,125 horsepower in war emergency power, amounting to over 2,850 horsepower combined. In comparison, the Daimler-Benz DB605 engine powering Italy's most advanced fighter, the Macchi C.205 volts, produced only 1,750 horsepower. This meant that a single P-38 had nearly twice the power of Italy's best single-engine fighter. However, the engineering required to manufacture the P-38's Allison V1710 engine was highly complex. The engine displaced 1,710 cubic inches, 28 liters, and demanded precise machining of 12 cylinders, 12 pistons, connecting rods, and a crankshaft capable of sustaining 3,000 revolutions per minute. This level of precision casting capability was a significant challenge, even if the necessary materials were available. The implications of this technical challenge were devastating. The P-38's overwhelming power advantage over its contemporaries could not be fully realized if the production of these engines was hindered by the lack of precision manufacturing capabilities. Examining the intricate components of the aircraft, Zappata meticulously documented each element, from the powerful supercharger to the sophisticated oil cooling system and the efficient radiator design. His assistant, equally intrigued, posed the question they both contemplated: could they replicate this engineering marvel? Zappata paused, considering the challenge, before responding. While building a single, reliable prototype might be feasible given ample time, resources, and skilled machinists, the prospect of mass-producing such a complex system proved daunting. The cooling system alone, a testament to American engineering prowess, utilized a liquid-based design with strategically placed wing-mounted radiators, optimizing both aerodynamics and thermal management. The American-made cores were marvels of precision engineering, with hundreds of minuscule tubes brazed together with exacting tolerances to prevent leaks while maximizing heat transfer. In contrast, the Italian radiator technology lagged years behind, resulting in heavier, less efficient, and more combat-vulnerable systems. The American design integrated robust armor protection, redundant coolant passages, and a glycol mixture capable of operating at higher temperatures than the Italian counterparts. As Mancini observed, tracing the coolant lines with his finger, "They've solved problems we didn't know existed." Zappata added, "They've solved problems we knew existed but couldn't afford to address." The counter-rotating propellers added another layer of complexity, with the left engine rotating clockwise and the right engine rotating counterclockwise, effectively eliminating the troublesome torque effect. The single-engine fighters faced a formidable challenge, necessitating intricate engineering solutions. Zappata's team scrutinized the reduction gearing, a critical component that converted the engine's 3,000 rpm to approximately 1,400 rpm at the propeller shaft. This precision assembly, with hardened steel gears cut to exacting tolerances measured in thousandths of an inch, was the key to transmitting the engine's immense power to the propeller. However, Domenico Russo, the metallurgy specialist, bluntly stated that their current steel quality and heat treatment capabilities were insufficient to replicate these gears. The gears needed to withstand 1,500 horsepower without failure, but their own gears would strip under half that load. As the examination continued, Zappata uncovered a pattern that he found deeply troubling. The P-38 Lightning was engineered with a meticulous focus on redundancy, serviceability, and operational versatility. Its electrical system employed a robust 24-volt architecture, featuring dual generators, one per engine. This redundancy ensured that if one generator failed, the other could power all essential components. In contrast, Italian fighters relied on a 12-volt system with a single generator, leaving them more vulnerable. The P-38's hydraulic system, responsible for operating the landing gear, flaps, and dive brakes, incorporated redundant pumps and multiple circuit breakers, providing a safeguard against combat damage. Italian fighters, on the other hand, often utilized mechanical systems or single-point hydraulic setups that were more susceptible to battle-related failures. The P-38's fuel system incorporated self-sealing tanks, a technology that Italy had only recently begun to implement, along with sophisticated cross-feed capabilities that allowed for flexible fuel management. The P-38 Lightning was a formidable aircraft, boasting an impressive arsenal that left its Italian counterparts in the dust. Each P-38 carried a potent 20mm Hispano cannon with 150 rounds, as well as 4 Browning M2.50 caliber machine guns, each loaded with 500 rounds. This concentrated firepower, totaling 1 cannon and 2,000 rounds of heavy machine gun ammunition, was a stark contrast to the Macchi C-205V's two 12.7mm machine guns with 400 rounds each and a single 12mm cannon with 200 rounds. The Italian engineers were astonished by the P-38's sheer ammunition capacity, which was 3 times that of its counterpart. As Mancini examined the intricate ammunition feed mechanisms, he couldn't help but marvel at the American engineers' creation of a true, flying battleship. The P-38 Lightning was an engineering marvel, designed to withstand the rigors of high-speed aerial maneuvers. Its electric ammunition boost motors ensured reliable ammunition feeding, even when the pilot was pulling intense G-forces during tight turns. Zappata, the engineer, diligently took notes, shifting his focus from technical specifications to production requirements. Each P-38 was a complex assembly, comprising approximately 50,000 individual parts. The engines alone contained over 6,000 components, while the electrical system spanned an impressive 8 miles of wiring. The hydraulic system relied on precision machined valves and seals, which proved challenging for Italian suppliers to reliably produce. Furthermore, the aluminum airframe required specialized alloys that were in short supply due to material shortages and Allied blockades. As Zappata contemplated these logistical hurdles, he realized the immense scale and complexity of manufacturing this advanced fighter aircraft. Filippo Zappata found himself confronted with a sight that filled him with a profound sense of despondency: the Lockheed P-38 Lightning sitting on the tarmac. This was not merely an enemy aircraft, but a tangible manifestation of an industrial revolution that had left Italy lagging behind. That evening, Zappata diligently composed his report from the confines of his office at Guidonia. Spanning 12 pages, the document delved into the technical specifications, including meticulous measurements, component analyses, materials assessments, and performance calculations. However, it was the final section, marked Strategic Assessment, that Zappata knew would be a source of controversy. He penned the words, "The Lockheed P-38 Lightning represents a level of aeronautical engineering sophistication that exceeds Italian manufacturing capabilities by a margin of approximately 5 to 7 years at our current juncture." The American aircraft showcases their nation's remarkable industrial prowess, surpassing our own capabilities. The Allison V1710 turbocharged engine, producing a staggering 1,125 horsepower, nearly matches our most powerful units, yet boasts superior high-altitude performance thanks to its turbocharging technology. Regrettably, Italian industry lacks the advanced metallurgy, precision machining, and quality control necessary to replicate this exceptional engine. Constructing a single prototype would demand 18 months and deplete resources needed for 20 conventional fighters. The turbocharger system alone embodies technological advancements beyond our current grasp, as the material science, precision casting, and high-temperature metallurgy required are simply unavailable within Italian industry. Furthermore, the counter-rotating propeller system, designed to eliminate torque effects, represents a level of complexity that exceeds our present capabilities. The airframe construction showcases aluminum alloy craftsmanship and shaping techniques that surpass our current benchmarks. The system's integration, including electrical, hydraulic, fuel, and armament, reflects a design philosophy prioritizing redundancy and maintainability over weight savings. This approach is only feasible with engines powerful enough to overcome the weight penalty. American manufacturing appears capable of producing these intricate aircraft in substantial quantities while upholding quality standards. Intelligence indicates production rates exceeding 200 aircraft monthly from multiple facilities, outpacing the average of 150 Italian fighter aircraft across all types, which is declining due to material shortages and Allied bombardment. The P-38 cannot be reliably manufactured with the precision reduction gearing we currently possess. The Italian Air Force found itself outmatched by the formidable P-38 Lightning fighters. Lacking the engine power, high-altitude capabilities, and firepower to engage these American aircraft effectively, the tactical approach should prioritize avoiding direct confrontation whenever possible. Zappata's analysis painted a sobering picture. If this advanced warplane represented the typical production capacity of the United States, Italy faced an adversary with overwhelming industrial superiority. The war could not be won through a war of attrition against an enemy capable of manufacturing such sophisticated weapons on a large scale. Zappata reviewed his report meticulously before signing it, aware that the technical details would be accepted, but the strategic assessment would likely be dismissed as defeatist. As an engineer bound by evidence and mathematics, he could not ignore the stark realities presented by the data. The following morning, Colonnello Angelo Tandy, the chief test pilot of the Regia Aeronautica, arrived at Guidonia to take the captured Lightning for a flight. Tandy was a seasoned aviator with thousands of hours of experience across numerous aircraft types, including every Italian fighter, Spitfires, and even a Messerschmitt Bf 109. He listened to Zappata's technical briefing with professional courtesy, but his expression hinted at a belief that the engineer was exaggerating certain aspects. After all, the common perception was that American aircraft prioritized quantity over quality, brute force over elegance. Tandy climbed into the P-38's cockpit with the confidence of a master of every aircraft he had ever flown. From the control tower, Zappata watched as the Lightning's engines roared to life. The Allison V1710 engine settled into a steady, synchronized rumble, causing the tower windows to vibrate. Tandy's movements were cautious as he familiarized himself with the tricycle landing gear and nosewheel steering during the taxi to the runway. The takeoff roll seemed unusually long to observers accustomed to the rapid leaps of Italian fighters, but when the Lightning finally rotated, it climbed at an angle that left Zappata in awe. 15 minutes later, Tandy landed, taxied back to the hardstand, and shut down the engines. He remained seated in the cockpit for several minutes before disembarking. As he finally reached the ground, his expression was one of. The pilot's report was accurate, and even understated certain aspects. At high altitudes, this aircraft was unassailable. Soaring at 25,000 feet, it continued to accelerate, with a climb rate surpassing anything the observer had experienced. The controls were heavy yet precise, offering excellent maneuverability. Visibility from the cockpit was outstanding. As for the firepower, the pilot paused before describing the devastating effect. He had fired a test burst, unleashing a thunderous barrage from the nose-mounted cannon and 4 machine guns, without any convergence problems. Simply point the aircraft at the target and pull the trigger. Everything in its path would be annihilated. Zappata nodded slowly, then inquired if there was any way to counter this formidable weapon. Tandy remained silent for a long moment, unable to provide a satisfactory response. The American fighter aircraft stands out for its exceptional performance at high altitudes and high speeds, essential for modern aerial combat. Intelligence estimates indicate they are manufacturing these planes on a massive scale, with projections of 500 units per month by late 1943. In contrast, our own production capabilities pale in comparison, struggling to reach even 50 Mach-E and 30 Fiat fighters per month. Meanwhile, our adversary churns out thousands of bombers, fighters, ships, and tanks, overwhelming us with their industrial might. As the lightning flashes in the distance, we are confronted with the sobering reality of fighting a nation that can outproduce us on every front. The Italian engineers embarked on a meticulous examination of the seized P-38 aircraft. Through extensive testing, they pitted it against their own fighter planes, scrutinizing its capabilities across various altitudes and maneuvers. The results were unequivocal. The Lightning outclassed its Italian and German counterparts in virtually every quantifiable aspect. At heights exceeding 20,000 feet, where bomber interceptions took place, no aircraft in the Italian arsenal could match the P-38's performance. The turbocharged engines were the key to its superiority. The P-38 Lightning's performance soared at high altitudes, where its rivals struggled to keep up. While Italian engines labored for oxygen at 21,000 feet, the American fighter maintained full power. Even the formidable German Bf-109G, with its potent DB-605 engine, saw a significant drop in capability above 25,000 feet. In contrast, the P-38 hit its stride in the rarefied air, its speed advantage allowing pilots to dictate the terms of engagement. Italian interceptors attempting to close in could be easily evaded as American flyers simply pushed their throttles forward and outpaced the pursuit. The P-38's concentrated armament in the nose proved devastatingly effective in mock combat, outmatching Italian fighters with wing-mounted guns that suffered from convergence issues. While those weapons were typically harmonized to meet at 300 meters, they were less effective at other ranges. The P-38's nose-mounted guns, however, had no such limitation. The Italian engineers were astonished by the exceptional craftsmanship they discovered upon meticulously examining the disassembled components. The welds were flawless, the machining was precise, and the materials were of the highest quality throughout, with no evidence of cost-cutting or compromises. As one engineer noted, every component appears overbuilt to a safety margin we cannot afford. While Italian design prioritizes maximizing performance from minimal resources, the American approach achieves superior performance through the use of superior materials and manufacturing processes. The philosophy behind this approach is to build to the limits of what's possible, with the assumption that some components may fail, yet the aircraft will still remain airborne. The P-38 Lightning's structural integrity was a testament to American engineering prowess. Its airframe featured reinforced components, exceeding the minimum requirements to ensure exceptional durability and resilience. The electrical system boasted an abundance of circuit breakers and redundancies, surpassing the typical Italian design standards. Likewise, the hydraulic lines were equipped with protective armor, adding weight but significantly enhancing the aircraft's survivability. This level of engineering reflected the United States' vast resources and technical capabilities. The P-38's legendary toughness was no mere coincidence, but rather a deliberate design choice from the outset. Zappata's comprehensive report ascended the military hierarchy, with the technical details subsequently distributed to Italian aircraft manufacturers. The instructions were clear. Identify and incorporate the relevant technologies into future projects. The strategic assessment ultimately reached the desk of Marão dell'Aria Rino Corso Fuggier, the esteemed chief of the Italian aviation industry. The Italian Air Force faced a daunting challenge. Fuggier 2446 meticulously reviewed the situation, then filed the findings away. There was little they could do. Italy 2451 lacked the industrial capacity to replicate American technological advancements. German 2456 support was primarily focused on their own programs. The best Italian engineers could manage was to optimize existing designs 2504 and hope that pilot skill and tactical ingenuity could overcome material disadvantages. But it wouldn't be enough. 25-12 everyone recognized this, yet no one could openly acknowledge it. On August 11, 1943, Tandy 25-19 took the captured Lightning into combat. Intelligence reports indicated a formation of 25-24 American B-24 Liberators returning from a bombing run on Tandy. 25-30 Tandy took off from Guidonia, climbed to the appropriate altitude, and positioned himself to 25-35 attack. Utilizing the Lightning's familiar silhouette, sneaking up unnoticed, he unleashed a barrage from his aircraft's arsenal at a straggling bomber. The concentrated firepower of the cannon and 4 machine guns tore into the Liberator. Tandy claimed the kill, potentially a B-24 named Bonnie Sue or the Lady Evelyn, depending on conflicting records. It was a minor triumph. An American fighter, captured and flown by Italy's top test pilot, had destroyed 1 American bomber. While useful for propaganda purposes, it held little strategic significance. The Lightning was grounded shortly after, lacking spare parts, maintenance manuals, and the logistical support that kept American P-38's airborne. The captured aircraft became a hangar ornament, never to be flown by Tandy again. The war continued its relentless march forward. Italy capitulated in September 1943. The airfield at Guidonia fell into German control, only to be eventually destroyed to prevent recapture. Zappata's report, a technical document, survived in archives, marking the moment when Italian engineers confronted the full scale of American industrial power and found themselves unable to respond. After the war, declassified production figures revealed that Zappata's estimates were conservative. The United States manufactured 10,037 P-38 Lightning aircraft of all variants. Each required 2 Allison V1710 engines, amounting to 20,074 engines solely for the Lightning program. The Allison V1710 was also used in P-40s, P-39s, and P-63s, with total production exceeding 70,000 engines. Italy's entire wartime aircraft engine production across all types paled in comparison. The United States' wartime aircraft production dwarfed that of Italy. While Italy's manufacturers churned out roughly 13,000 units, America's output exceeded 300,000 aircraft, over 5 times as many of a single advanced engine type alone. This disparity permeated every category, with American aluminum production in 1943 surpassing Italy's entire wartime output. Assembling complex aircraft with a precision that Italian craftsmen struggled to emulate, America's factory workers, many of them women new to manufacturing, played a pivotal role. Decades later, in the 1960s, a retired Italian aviation engineer, Filippo Zappata, reflected carefully on his examination of a captured P-38 fighter, acknowledging the inevitability of Italy's defeat. The sight of those engine cowlings on the American fighter plane was a stark reminder of the immense industrial might that the United States had brought to bear in the war, as Zappata observed. The P-38 Lightning, with its 50,000 individual components, including 2 of the most complex aircraft engines ever built, was just one example of the advanced warplanes that the Americans were producing in large quantities. Zappata's calculations of the man-hours, materials, precision machining, and quality control required to manufacture this aircraft made it clear that the Axis powers were facing an industrial juggernaut that had barely begun to flex its muscles. While the Soviets and Germans were struggling to build a mere 100 fighters, The Americans were simultaneously producing multiple advanced aircraft types, each a testament to their unparalleled industrial capacity. Every month, they were constructing thousands of aircraft, all of which were as capable or even more so than our finest designs. The historian inquired, "Have you ever flown a P-38?" Zappata smiled and replied, "No, I haven't," as Tandy chimed in, "but I declined. I'm an engineer, not a pilot." However, Zappata explained, "I didn't need to fly it. The numbers told me everything: the power-to-weight ratio, wing loading, thrust available versus thrust required. The mathematics of flight performance are uncompromising." The P-38 boasted superior power, altitude performance, firepower, range, and systems. It was a superior aircraft, and there were thousands of them. The captured P-38G at Guidonia never saw extensive combat service, only undertaking a handful of test flights and participating in a few operations. The captured Lightning's journey was a testament to the complexities of modern warfare. Initially, it had seen action in combat, only to be relegated to a hangar, a 30-22 technological marvel frozen in time, a relic of a war already lost. Engineers 30-28 who grasped its implications were powerless to alter the course of events. Ultimately, the story of this aircraft embodied the 30-35 dynamics of industrial capacity and the mathematical realities of modern conflict. Italy 30-41 entered the war with a proud aviation heritage, skilled pilots, and talented designers. Yet, they lacked the 30-46 industrial foundation to match American mass production capabilities. The absence of resources to develop advanced technologies, such as effective 30-59 turbochargers, and the inability to construct with American safety margins 31.04 left them struggling to close a widening gap. Each subsequent month brought further evidence of this reality, as meticulously documented in Filippo Zappata's engineering report. Two Allison V1710 engines, generating a combined 2,500 horsepower, maintained sealed performance at an altitude of 25,000 feet, thanks to their turbochargers. Counter-rotating propellers eliminated torque effects, while the concentrated nose armament, with 2,000 rounds of ammunition, exemplified the system's integration and redundancy that prioritized operational effectiveness over weight savings. Underpinning this formidable aircraft was an industrial machine capable of producing such complex designs at rates that rendered Italian production insignificant. The captured P-38 remained on the Guidonia tarmac for only a few months, but for the Italian engineers who examined it, measuring its components and calculating its implications, that aircraft represented a turning point. The realization dawned that this conflict would not be won through bravery or expertise, but rather by the might of industrial production, resources, and manufacturing capabilities. America possessed these advantages in ample measure, while Italy lacked them entirely. The speed of the Allied advance served as undeniable evidence, and no degree of Italian technical ingenuity could alter this fundamental reality.